Okay. Let's do this. We were here last time when there was a time for quiz. So this example number 2.1, we have a point given in Cartesian coordinates where x is -2, y is a 6, and z is equal to 3. Okay, first let us convert this point in cylindrical coordinates. Oh, I should use black. To cylindrical coordinates. In cylindrical coordinates, we have rho equal to x square plus y square square root. So this is 4 plus 36 square root equal to square root of 40, and square root of 40 is 6.32, and we have tan of y equal to y over x. Y over x mean y is a 6, and remember, on xy plane, when we are on the ground xy plane, this point is in the second quadrant. When we are on xy plane, this point is in second coordinate. Quadrant. So like here, let me just here. You see, rho square is x square plus y square, tan phi is y over x, and z is z. So same thing we are using here. Y over x. Y is a 6 over -2. So this implies phi equal to inverse tan arc tan 6 over -2. So we have a tan arc tan of -3, and the answer is negative. Answer is -1.249. -1.249. But this -1.249, so what tan is giving us this answer is clockwise in the fourth quadrant, but actual angle is counterclockwise. What we will do, we will say pi minus pi minus this number, whatever it is, pi minus 1.12.249. It is 1.8925, but this is in radian. Okay. You change this, either you change your calculator mode into degrees, or if it is in radian, then we will multiply this by 180 and divide by pi. And that 1.8925, and that give us 108.43 degrees. 108.43 degrees. Any question here? So when there is something negative, you can do this. If angle is in this quadrant, yani both x and y are positive, then whatever is angle, keep it, use it. And when x is negative and y is positive, we are in quadrant 2. So do what? Let me do this. Do not take this ishara. Do not take the sign. Okay? Do not take the sign without positive or negative, because computer or calculator does not know this negative sign is with x or it is with y. So without this one, you get the answer. Without this, you get the answer. Yani do not take this ishara. Okay, whatever you get, then if x is negative, y is positive, then the angle will be pi minus theta. If x is negative, y is also negative. The calculator or computer give you theta because it does not know they were negative. Then whatever value of theta you get, you add pi here. And if x is positive, but y is negative, then do what? 2 pi minus theta. So you need to remember this from calculus, that if we have angle in different quadrants, then how we get the actual angle? X positive, y positive, same angle. X negative, y positive, pi minus theta. And x negative, y negative, pi plus theta. X positive but y negative, 2 pi minus theta. So this is what we are doing here. Now what left is z, and z in cylindrical coordinate is the same as z in Cartesian coordinate, and that is 3. So the point P in cylindrical coordinates, it is first is 6.32, which is rho, then 108.43 degrees, and then z, it is 3 in cylindrical coordinates. Anyone has any question here?
Doctor?
Yeah.
For the calculation of phase here or phi, How we can calculate it without calculator?
Without calculator,
I think this number is
this is, yeah, this is not possible. You need to do without, you need to use your calculator.
okay.
And if you are asking with the exam or quiz point of view, if numbers are like this where you cannot do without calculator, calculator will be allowed. Otherwise, I will give you numbers where you can do it without calculator.
Okay.
So these are rho, theta, z. Rho, sorry, rho, theta, z. Okay. No, but do we use, what do we use in here? Rho or
Pi, rho,
phi?
pi, z. Yeah,
Yeah, I think we use here
yeah, it's there.
phi,
Rho,
not
pi,
theta.
z. Yes.
Yes, we use phi. So it is phi. But the rule which I'm telling you here, that is for any angle. Okay, now next thing is two spherical coordinates. In spherical coordinates, the spherical coordinates are r, theta, and phi. R is x square plus y square plus z square square root. So it is 4 plus 36 plus 9 and square root, and you see it is 7, so we don't need to use calculator here. Then we have theta. Theta is equal to tan of theta equal to
Tangent inverse of y over x. I think,
here
but
theta equal to z over r, yani cosine theta.
okay.
So it is r theta phi. Phi is the same y over x. You are seeing here on the screen. Tan phi equal to y over x. So it is same, but theta is cosine inverse z over r. So cosine theta equal to z over r. Z over r. So it is cosine inverse of z is 3, r is 7. So I'm using here my laptop, my MATLAB on my computer. So a cosine of 3 over 7. And then I multiply by 180, so 64.32. So it is 64.32 degrees. I'm writing here directly degrees. And then phi is equal to tan inverse y over x, and we did it before here. And here it is, if you, for example, has some MATLAB, if you are using MATLAB like I'm using MATLAB, now I don't have a calculator. So then the answer will be in radian. And then how to convert radian into degree, 180 over pi. And before that is how to deal with the negative sign if x or y or both either x or y or both, they have negative sign, then how to deal with I just explain it. Now tan of phi, we calculated it. Yes.
For X and Z, we use the same four quadrants.
Phi.
Like if Z is less than 0 and X is bigger than 0.
Yeah, that rule is the same rule will be applied.
Oh, okay.
That is a rule for any angle theta. Now here R will always be positive. R will always be positive. You know, in case of tan, we have the general formula for tan is tan of theta is equal to y over x. But sine of theta is equal to y over r, any opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, where this r is like this. You remember?
Yes.
So here r will always be positive. It depends on sine of x only.
X
Now
and
here
Z
is not
for theta, right?
here in this situation sine of z only.
Oh yeah. Sorry, I got it.
Now tan inverse y over x, this is something we got before. So point P in spherical coordinates is 7 is r, and theta is 64 point how much degree? 32 degree.
Victor, I found it in my calculator 64.60.
62. Yes, I wrote it wrong because in my head it was 32 from 6.32. 64.62. You did with your calculator?
Yes, Victor.
Excellent, excellent. So far we just convert this. Here it took more space because I explained you these other things, but actually it will be just 2 lines. Even here we can do this r theta phi just in 2 lines and then write the point. Okay. Now this was one part of the question, convert from Cartesian to spherical to cylindrical. Now second part of the question is we have a vector. We have a vector, and let me say this is part A of the question with a point P, and part B of the question is with vector A. Y, we have vector A. They are not writing anything on the vector, but just for us to remember, this A is a vector because there in book they make it bold. Here I cannot make it bold, so I put arrow here, and that vector is yi. Now here we are using ya sub x plus x plus z ay plus 0 az. So this vector is in xy plane because z component is 0. And you know here capital A sub x is y and capital A sub y is equal to x plus z, and capital A sub z it is 0. Yani small ax, small ay, small az are 3 unit vectors in the x direction, y direction, z direction. And capital AX, capital AY, capital AZ are the x, y, and z components of the vector. So here this vector is at this point. Evaluate vector A at point P in Cartesian, cylindrical, and spherical. Now in Cartesian, what is the vector A at point P? You can also, just to maybe remember, we can put a bracket here and point, or at the end I will write y. What was y? It was 6. So 6ax plus x plus z.
1.
X is -2, z is 3. So plus 1 ay at, so let me write here a equal to this in Cartesian. In Cartesian at point P. So vector is in Cartesian at the Cartesian coordinates P. So let me also make it even more clear at P, which was -2, 6, and 3. So it is more clear. Now we will convert this vector into, first let us do this to convert this into cylindrical. And the equations which convert into from say Cartesian to cylindrical, I have written before. Let me just do copy and paste here again for us to use and to remember. From Cartesian to cylindrical, these are transformation equations which will be given to you. So let me say convert A to cylindrical. So this is what we are doing right now. You need to use these transformation equations. With this transformation equations, rho component, phi component, z component. Cosine of phi. Maybe we use a number here, but it is easy to use this sine, cosine, phi. We know phi. Sine of phi and 0 minus sine phi, cosine phi, 0, 0, 0, 1. Here we will use ax, as I have written ax above. Ax, ay, x plus z, and 0. So this become y cosine phi plus x plus z sine phi. Then negative y sine phi plus x plus z cosine phi plus 0, 0, 0. Second, the third one is 0. Okay. So this is equal to, we know that let me do it here. We know that what is a phi? Cosine of phi, yani cosine of 108.43, 108.43. You can use that angle and find cosine of phi. Someone do this and tell me what is the value of cosine phi. Now put your calculator mode in degrees.
minus 0.316.
Minus 0.316.
316.
Also, we need to use sine phi, yani sine of 108.43 in degrees, and that
0.
will be 0.949. Okay, so with this, a rho, which is y, what is y in our coordinate system? 6 multiply negative 0.316 plus x plus z is 1 and multiply 0.949. Someone do this and tell me the answer.
minus 0.947.
9487. Yeah, 947. You are right, absolutely right. Then what is next thing is a phi. A phi mean negative 6 multiply sine phi 0.949 plus x plus z is 1 and then multiply cosine phi, yani negative 0.316. So this will be
minus 6.008.
8. And the third component is az is, for the sake of completeness, az is 0. So the vector A negative 0.947 small a rho, negative 6.008 small a phi plus 0 small a z. This is in cylindrical. So we got this vector before. We have 6ax plus 1ay. Now we have this vector. Vector is the same. Vector is exactly same, but representation of this vector in different coordinate system. So now the third one is what I have written, convert A to spherical coordinates. Convert vector A to spherical coordinates. For this, again, we will use what will be given to you also in the formula sheet. How to convert from Cartesian to spherical. This one. So let me repeat that process here. A sub r, A sub theta, A sub phi. Sine theta cosine phi. Should we save our space? You know our AX is what? AX is Y and AY is X plus Z and it is 0. So this will be Y sine of theta cosine phi plus X plus Z sine theta sine phi plus 0. And second one will be Y cosine of theta cosine phi plus X plus Z cosine theta sine phi, and then we have 0 times negative sine theta is 0. Then third one will be negative Y sine phi plus X plus Z cosine phi and plus 0. So, you know, what was theta before? Here we found a theta 64.62. So theta is 64.62 degrees. And what do we need here? Sine of theta and cosine of theta. Can someone do this for me? Sine theta.
Sine theta dictor 0.9034.
9034, 64 degrees.
Yes.
9034. And cosine theta
0.4286.
4283.
6.
6.
Yes.
And we need here sine phi cosine phi, and sine phi 0.949 with phi equal to 108.43 degrees. Sine phi 0.949 and cosine phi is negative 0.316. Negative 0.316. So now what is AR? 6 multiply sine theta. Should I leave this for you? You can do this. This is just simple multiplication of these numbers. Shabab? What do you think?
You can write it without numbers to remember that we should do.
No, you see here, AR, the first component AR is y times sine theta times cosine phi. AR is y times sine theta is 0.9034 multiply cosine phi, and cosine phi is a negative 0.316. Plus second part is x plus z, which is 1, and multiply sine of theta, which is 0.9034 4 and multiply sine half of phi, which is 0.949. And you need to calculate what is this using your calculator. Similarly, a theta, it will be 6 times cosine theta, and cosine theta is 0.4286 multiply cosine phi negative 0.316 plus 1 multiply cosine theta and 0.4286 multiply sine phi 0.949 and calculate what is this. Someone can do these calculations. And a phi, it is negative 6 times sine phi. Sine phi 0.949 plus x plus z, which is 1 time cosine phi. Cosine phi is here negative 0.316. So if you have done these calculations, you can tell me the answer. If not, that's fine. So these are A. So we will
Sir,
write.
I did the calculations.
Okay, so if what is AR?
Minus 0.86.
8
6.
and A theta.
Minus 0.406.
A phi.
Minus 0.01. Minus 6.01.
Sorry?
Minus 6.01.
Minus 6.01.
Yes.
008 means 01. So then this is equal to negative 0.86 small a r. Negative 0.406 small a theta. Negative 6.01 small a phi. Okay. So this is the final answer, which is exactly correct. In your book, they have done long, say, this is square root and this or that calculations, but we directly use our calculator and find AR, A theta, A phi using sine theta, sine phi, cosine theta, cosine phi values. Okay, this is example 2.1. Then in your book, I'm seeing here practice problem, practice exercise 2.1, convert point P, point T, point S to from Cartesian to cylindrical and spherical, same thing. Transform this vector to cylindrical to spherical, same thing. Evaluate Q, yani the vector name is Q. Capital Q is the name of the vector, like we are using name of the vector as capital A. Evaluate Q at point T in 3 coordinate system, same thing we did here. And its solution is also given in the book. You can verify your answer, but try to do this in your own way. Similarly, there is another practice problem 2.2. Express the following vector in Cartesian. So first vector is given in rho, phi, and z. When a vector is given in rho, phi, and z, it is in cylindrical coordinates. So you convert from cylindrical to Cartesian. And also there is a vector given in r and phi. It means this vector is in spherical. Convert into Cartesian. And no point is given. And therefore, this will be simply in the symbolic. No numbers, no calculations. Just you convert into symbols. Using what? using the transformation equations. You will leave x component, row component and the other components as it is. Before we are using here x equal to 2, negative 2, y equal to 6 and z equal to 3. But here in practice problem 2.2, you don't need to use that. You need to just convert into x, y, z. Okay. Then the next thing here is constant coordinate surfaces. Section 2.5 here is constant coordinate surfaces. Constant coordinate surfaces. Number 1. Cartesian coordinates x, y, z. Now x equal to constant. What is this? What is x equal to constant? When value of x is constant in 3-dimensional space. I put arrow.
It's plane.
A plane parallel to x, y plane. Exercise 12.5 in Math 201. And similarly, y equal to constant is a plane parallel to xz plane. And z equal to constant is a plane parallel to the ground, any x. No, x equal to constant is yz, not xy. The other two, yz plane, xy plane. So this is number 1. Number 2. Cylindrical coordinates, which is rho, then what? Phi, then what? Z. So rho equal to constant. What does this mean, rho equal to constant? When rho is not changing, phi is changing, and z is changing.
Cylindrical. Cylindra.
Okay. Let me do this. Give me just one moment.
I mean infinite cylinder.
Just give me 1 second. And let me copy this thing here. Rho. What is rho? Rho is a distance of point from z-axis. So now this distance is constant. Distance of point P from z-axis is fixed. Now theta, phi is changing. So we can go all around this z-axis when phi is changing. Z is changing. We can go up and down. So what is rho equal to constant? A surface in which rho is constant. Just think and tell me. It is a cylinder. In cylinder, you have a fixed pipe with fixed radius. A cylinder of constant radius, let me write rho. Since rho is constant, so it will be a cylinder. Is it okay, Shabab? Clear?
Yes, Doctor.
A circular cylinder. Now, number 2 here is phi. Phi is constant. So we are not moving in the circular direction. Rho can be small or big. So rho can be small or big. Z can be small or big. So what do you think this will be? A plane like this plane. I'm putting here this red color shade. And this plane is going from z-axis to infinity. I mean, making angle phi with xz plane. A plane. This is a plane. Actually, since it is starting from z-axis, we can also say like this. It is a half plane. We say it is a semi-plane. It is a semi-plane with the edge on z-axis. And making angle phi with the xz plane. A constant angle because phi is constant, making a constant angle. What constant angle? Phi. A constant angle phi with xz plane. Okay, Shabab, is this clear?
Yes, Doctor.
Now, number 3 is z equal to constant. Mean we are not going up or down. We are not going up, down. Rho can be small or big. Phi can be any angle between 0 and 2 pi. Rho can be small or big. But we are not going up or down. So what do you think this will be?
Circle. Plane.
A plane on a plane. Actually, it will be what?
A circle on the XY plane.
This circle is going to infinity. A plane. Which plane?
XY plane.
XY plane on the ground. On the ground, you can move anywhere. So it is a plane. Which plane? XY plane. So let me write in the same line. Z equal to constant is XY. Not just XY plane. That is when Z is 0. So a plane. Same like in Cartesian. A plane parallel to XY plane. Because Z is same in Cartesian. And what was Z in Cartesian? A plane parallel to XY plane. And this is also a plane parallel to XY plane. So this is number 2. Number 3. Spherical coordinates. R, theta, phi. Okay. Let me also do the same thing and copy and paste that figure here, which can and will help us to be able to write these equations. R, number 1, R equal to constant. Mean a point can move in the increasing direction of theta, in the increasing direction of phi, but it cannot go away or come near to the origin. So distance from the origin is constant. What do you think it is a?
Sphere.
We can also a sphere. We can also see from this one x square plus y square plus z square equal to r square, and it is some constant k. So what is this? Equation of a sphere. You are right, absolutely right. Now, number 2 is theta. Now, theta goes from positive z-axis to negative z-axis. So, theta is a constant. Let me see who thinks something, some surface when theta is constant. Shabab.
Doctor?
Yes?
My time is up. It's 10:22 now.
Oh, okay. So, theta equal to constant is a
circle.
Cone. Theta equal to constant is a cone. Okay. And number 3 is phi. Phi equal to constant is a semi-infinite plane. Take any value of phi and move any use or make the other variable r and theta variable. Theta goes from positive z-axis to negative z-axis. So this is why we are saying it is semi-infinite plane. Let me take the attendance and then you are free to leave. See you tomorrow, inshallah. Any question? I'm here. No question. You are free to leave.
Thank you, Doctor.
You are very welcome.
Thank you, Doctor.